Hello everyone. In this video we are going to discuss about LCD. We all heard about LCD, which means liquid crystal display. A lot of applications we are seeing LCD screens. We know about the LCD display in television, computers, and in gaming devices. Lot of places we are seeing the LCD panel display. What is an LCD? It is a flat panel display used for electronically displaying the information such as text, images and moving pictures. Here we are using the LCD for displaying the information. The information such as text, images and moving pictures are displaying. Here moving pictures means videos are displaying in LCD. Moving pictures means here the still pictures are running in faster to get a video. That's the basic construction of a video signal. That means moving picture is simply a video. So to display the information such as text, images and moving pictures we are using the LCD. Basically, LCD is an electronically modulated optical device. It's made up of number of pixels filled with liquid crystals and arrayed in front of a light source called backlight or reflector to produce images in color or monochrome. Here there is a term called pixel. Pixel is the basic element of the picture information. Basically, pixel is the picture information. Number of pixels filled with liquid crystals and arrayed in front of a light source. Here the LCD panel are placed in front of the light source, means backlight or reflector, which produce the images in color or monochrome. Monochrome means the grayscale distribution. You have mainly black and white colors come under the monochrome images. Black and white means shades of gray level, and in color different ranges of colors are available. So basically LCD is an electronically modulated optical device. It's made up of number of pixels filled with liquid crystals and arrayed in front of a light source to produce images in color or monochrome. Both type of images are available both in color and monochrome. On applying the electrical voltage to the LCD, the electric voltage to layer of liquid crystal, thereby inducing changes in optical properties. When we are applying the electrical voltage to this LCD, the liquid crystal optical properties changes due to this induced voltage, and it uses the light modulating properties of liquid crystals combined with the polarizers. Light modulating properties of liquid crystals are utilizing here for displaying the images and pictures. LCD is used in lot of applications such as computer monitors, televisions, instrument panels, gaming devices, etc. Here we are using the liquid crystal. Liquid crystal are the materials with a structure that is intermediate between that of the liquids and crystalline solid. So a liquid crystal property lies between that of the liquids and solid. Liquid crystal do not emit light directly. So here we are using a backlight or reflector. Simply a light source are using. We call this light source as a backlight or reflector to produce the images in color or monochrome. So with the help of this light source, the liquid crystals are emitting the light, and as in solid crystals they arrange themselves in ordered pattern. Like solid crystals or liquid crystals, liquid, they can arrange themselves in ordered pattern. The liquid crystals can exhibit polymorphism, that is they can take on different crystal patterns, each with unique properties. They have different structural patterns. Each pattern has unique properties. This is the property called polymorphism. LCD utilizes either pneumatic or symmetric liquid crystals Two type of liquid crystals are used by the LCD, pneumatic and symmetric liquid crystals. In pneumatic liquid crystals, the molecules of pneumatic liquid crystals align themselves with their axis in parallel. On seeing the figure, first one pneumatic is represented. Here the molecules are arranged in parallel. Their axes are arranged in parallel. And the second one is the symmetric liquid crystals. In this, the molecule arrange themselves in layered sheets within different symmetric phases. These symmetric phases are selected by the applying voltage. When the voltage is applied to this liquid crystal, they induce some charges in the liquid crystal. Due to this induced voltage, they select the type of the phase they have to work. The molecules may take on different alignment related to the plane of the sheet. In symmetric liquid crystal, molecules arrange themselves in layered sheets within different symmetric phases. These are represented in the second figure, symmetric type A. The different types of symmetrics are available here, represented only symmetric type A. Basically, LED uses pneumatic and symmetric liquid crystals. Next one is the working of LCD. In LCD working, first using a backlight source, then polarizer, then glass sheet, negative electrode, liquid crystal, positive electrode, glass sheet, polarizer and displayed image. When light rays are emitted by the backlight source, it gets polarized by the polarizer. And these polarized light signals are passed through the glass sheet and reaches the negative electrode. From the negative electrode, this energy signal reaches the liquid crystal. These liquid crystals undergoes changes due to the optical properties. When induced voltage on the liquid crystal changes, its optical property also changes. Based on that changes in the optical properties, the changes in light signal falls to the positive electrode. From the positive electrode that reaches the polarizer through glass sheet and then to displayed image. This is the working of an LCD. Basically, LCD works with the help of a liquid crystal, polarizer and a backlight source. Mainly three important portions are available in an LCD. They are backlight source or light source. Simply we call it as light source, and polarizer and a liquid crystal. The polarization are done by the polarizer. The backlight in liquid crystal display provides a light source behind the screen. Here we are placing the light source behind the liquid crystal display. From the light source, the light rays are emitted and through polarizer it reaches the liquid crystal. This light is polarized, meaning only half of the light shines through the liquid crystal layer. The liquid crystal are made up of a part of solid, part liquid substance that can be destroyed by applying electrical voltage to them. They block the polarized light when they are off but reflect red, green or blue light when activated. Each LCD screen contains a matrix of pixels that display the images on the screen. Here, matrix of pixels are available in an LCD screen. Based on the voltages or based on the amount of energy reaches the LCD screen, according to that the images are displayed. Each pixel has a red, green and blue. We simply call this red, green and blue as RGB subpixels that can be turned on or off. When all this of a pixel subpixels are turned off, means all are in off state, then it appears as black. When all the subpixels are turned on, then it appears as white. By adjusting the individual levels of red, green and blue light, millions of color combinations are possible. In this way, by arranging the range of or intensity of the red, green and blue color, we can develop number of combinations, color combinations. Earlier stage LCDs has had passive metric screens. These passive metric screens are controlled by individual pixels by sending a charge to their row and column in a matrix. But such type of LCDs has an advantage that it seems appearing blurry when images move quickly on the screen. So these disadvantages are removed by using the active matrix technology. Nowadays we are using LCD with the active matrix technology. Active matrix technology contains thin film transistors. Here we are developing the thin film transistors by capacitors. These transistors include capacitors that enable individual pixels to actively retain their charge, because we are using capacitor to store charge. Therefore, active matrix LCDs are more efficient and appear more responsive than passive matrix displays. That's why we are using active matrix technology nowadays. These are the explanation of LCD working. In this video, we discuss about what is an LCD and how an LCD work and what are the important parts or important constructions in an LCD. And that's all in this video. Thank you.